Welcome everyone to the EOcafe. This is the 101st EOcafe. As you'll recall, we had our 100th cafe last time out. It seems a long gap. It seems a long time since we were in the EOcafe, but it's nice to be here. Today we're going to be talking about one of these best practices projects on rail and road, and we have a number of guests for that. But before I launch in, normal rules, please keep your microphones muted unless I specifically ask you to join the conversation. Feel free to use your camera, even if I can't. It's nice to see people. If you have any questions or comments to add, then please just put them into the chat, and then we'll try and pick them up from there. And if we come to it, then we will take your question and ask you to come in live to pose it. So just the normal process, normal rules. So that's it. Welcome. And again, for people just joining, my camera's not working for some reason. Well, the camera's working, but it's not recognized by Zoom for some reason. So all you'll get from me is a black square today by the look of it. So best practices. We've had, this started back in 2009, 2010, when we did a best practice on the oil and gas sector, which was I think a very successful project and established a lot of very good links. Since then, we've had similar looks in the EOcafe at insurance, wind just a few weeks ago, Arctic shipping, finance, raw materials, agro-insurance, and I think there are others that we haven't had in the EOcafe, but there have been other projects. But those we've all looked at in the EOcafe. They follow more or less the same process of identifying representatives from a sector, interviewing them on their needs for information, often collectively as well as individually, identifying which EO services and products are relevant for that sector, and then putting together a mapping with example cases where the EO product has or can serve the sector. But we'll hear variations on that from the project today. So we're looking at the best practice dealing with road and rail, and we have 3 members of the project team, which is executing this analysis. 2 on the screen you see now. Marius Coleman, who is a consultant with Novaspace, and Enes Hissam, who is the EO project manager at GMV. And maybe we also have Federico Travorelli in the call. Unfortunately, Anna Catherine was going to join as well, but she had to call off. So maybe we can start in a sort of customary way. Marius, Enes, just introduce yourselves to our audience and tell us a little bit about your background and where you come from.
Sure.
Who wants to go first? Marius, yeah.
Yes. So yeah, Marius Koman, consultant at Novaspace based in Munich. I'm working mostly on projects related to EO and PNT and the enablement of space solutions in end user industries. So from sustainable supply chains to infrastructure, most of the time. My background is in finance, international law, and informatics. So I'm not a remote sensing expert, as is Enes. But yeah, I can bring a bit of a broad business perspective and also data analysis perspective to the project.
Thanks, Marius. Anas Hissam. I'm working as Earth Observation Project Manager at GMV. My work is mainly using AI analytics and remote sensing analytics to derive insights from Earth observation data in different sectors, including finance, agriculture, energy, and transportation. My background, as Marius mentioned, is in remote sensing and GIS. Yeah, nice to be with you today.
Yeah, well, welcome to you both. I'm looking forward to this discussion because it's a sector that we looked at in some detail within the SEBS work that we did. We did three specific cases on roads. We didn't specifically cover rail, but rail was part of the case where we looked at in Norway, along with Italy and Portugal were the other two countries. And we also dealt with it as a specific sector in the transversal study, where we looked at why was there a difference in take up between different countries and different organizations. And that led us to do some further analysis. And I think it will be interesting to hear your conclusions in respect to that as we go on. But before we dig into that question, perhaps we can start by just getting an overview of the study and the work that you've been doing, and so tell us a little bit about, talk us through the study, Marius, if you will.
Yes, of course. Together with McKinsey, who is the third consortium partner in our consortium, we started by interviewing stakeholders, doing our desk research, as did every EO best practice project before us, to map user needs and then translate them into geospatial user requirements. So from a qualitative standpoint, analyzing the business processes from the planning of transport infrastructure to the maintenance and operation, up to decommissioning or repurposing. And then we looked for use cases to translate them to user needs and then requirements in the end. After that, we mapped the EO capabilities. So starting with satellite systems, resolution, swaths, you have it. And then also specific products and value-added services that are available to road and rail end users. And in order to, first of all, of course, show the capabilities, but also the limitations of the technology to the end users. And then to find specifically gaps and the reason where these gaps originate from between the user needs and the EO capabilities and offering. Based on this user feedback and this analysis, Enes and the team at GMV have then developed 3 different risk products, demonstrator tools related to flood risk, extreme rainfall risk, and ground movement risk. Which then were shown to a number of stakeholders, and we got some feedback on that, which was very, very helpful also to inform, together with the previous analysis, of course, the formulation of best practices, where we tried to outline the main barriers to adoption of EO in road and rail, and also recommend some targeted actions and timeline to overcome these in the future.
Okay, Enes, feel free to jump in if you feel you want to add anything.
Sure.
This is where it's a bit inconvenient to not be seen, because I could be gesturing as well. But anyway, so okay, so that's the sort of the process. What do you consider to be the main outputs? What are the main results from the study? So you talked about the barriers and the processes. What about the I mean, we did a mapping of the different requirements, the needs, mapped to the different types of EO products that could be used. We presented that in a certain way. What are the main results coming out of your work?
Sure. So I think to boil it down to 1 or 2 clear messages is, I think first of all, the good news is the technology is there. It's not so much a problem of resolution or technical capability. It's much more to deliver this value add that EO could technically deliver into the road and rail industries to the end user in a way that is understandable, easily integratable, and shows this clear value proposition towards what this means for the business process. Enes, maybe you have something to add from a technical side.
Yeah, I can add for that, because after we as Marius mentioned, after we developed the products on the virtual platform, we have engaged with many stakeholders in the rail sector. So as one thing which is like important that the rail industry has explored a lot the usage of remote sensing in different countries in Europe, but there is a big issue, which is the pilot trap. So it has been always like there are pilots using Earth observation in the rail sector, but to convert this pilot to operational service, this is, I think, the part that as Earth observation community, we should work on it. Also, additionally, in that sector is very keen about accuracy. So because it works, people are inside the trains, and we are talking about the lives of the people. But Earth observation cannot compete with the terrestrial solutions in terms of accuracy. So as Earth observation community, when we talk with the people in those sectors, we should not go that way in terms of the accuracy, because we cannot meet that. But we can talk about the other advantages of using Earth observation, including historical records, wider coverage, and frequent updates, something like that. So those, yeah, I think some of the things that we found during the work.
So did you find a good knowledge of what could be offered? If you say that the barrier is not technical, were organisations that you talked to rather familiar with what satellite could provide, or were they sort of ignorant of the possibilities?
So in this industry, so also I can leave the door for Marius afterwards. In those industries, there are two groups of people who work with innovation in the rail industry. So those people are aware of the technology. Okay, but on the other side, this industry is very regulated, and some of the people still till the moment works with paperwork. So those two kind of people there. So in terms of the people who work with innovation, I think they are aware of the technology, but one of the limitation that we found that and the big barriers is this sector is very regulated. So imagine now Earth observation, we have a technology. To adapt this technology in the sector, it can take up to 3-5 years until we implement this technology there because of the regulations. And after 3-5 years, you can find a new technology is coming. So the regulation part is one of the main big barriers for using Earth observation within those sectors.
And if I might add to that.
Marius, no, carry on, Marius. Sorry.
Yeah. So I think it's first of all, when we talk to stakeholders, especially at the beginning as well, you talk to the technical stakeholders, right? These are, I think, what Enes was referring to as the rail innovation people, where yes, there is an understanding of the technology, but not always a comprehensive understanding of how to integrate this with the existing solutions, because EO, as we see it, is less likely to be a standalone solution, and the demonstrators are also not standalone EO tools. These are tools that integrate terrestrial data sets with an EO layer exactly there where the EO layer can provide a benefit, which would be a continuous coverage, the historical archives, Enes has mentioned. Consistency of data, which is for railway, is a big topic with inter-European railway, right? You need the same kind of data that then can be validated in order to be regulatorily approved or used as reporting numbers. So it's for sure that. But then on the other hand, you have the people that a lot of the time determine the budget and where the budget goes, and these are usually people that do not understand the EO offering quite yet, and asking more for what's the euro value of this solution? Why would I invest in this? And then those people, of course, you need to provide a good overview of what the technology can actually do or not do. Maybe to add one small anecdote, we had an interview where we explained what EO is and where we see potential value. And then the question was, well, could we, after a storm, see a branch that fell on the railway? And then, of course, this is then the other way of the spectrum, right? Where you have to explain that EO is not what you can see in sci-fi movies. So yeah, it's a diverse group of stakeholders to address.
Yeah.
Okay.
Yeah.
I'm interested to explore the regulation side, but maybe we come back to that a little bit later. As I think it would be interesting to understand what you found as being the main needs of the two sectors. What is it that they're looking for, apart from detecting branches that have fallen on the rails or the road? Yeah.
Yeah. So in terms of the main pressing user needs, so we've summarized them in our work package 1.2 report, if anyone would like to access that as well, is related to different kind of pain point themes, as we call them. So one of them is climate and severe weather. It's the one big topic that is relating to a lot of industries, but for road and rail, they cannot move their assets easily. So assessing risk when planning new infrastructure, but also assessing risk in the operation of existing infrastructure and also in decommissioning decisions is quite important. Because in the end, what EO can provide here is maybe the correct risk assessment, but of course it does not change that the natural hazard event is occurring, right? Then there was a large, let's say, theme about demand. So could EO potentially help with the demand estimation? This is again relating to planning of new infrastructure. So there were also some things that are technically infeasible with EO. So there's no 30-year archive of how many cars go on which road, right? But this was also a question that we've gotten. Is this something possible? Then construction monitoring, as there's a lot of theft. So this is also an expensive area for them in terms of security, where probably EO can help a little bit less. But then on the other hand, also construction progress monitoring, which can help them to control these projects that are sometimes very far off headquarters. And then, of course, all topics related to targeted maintenance. And I think there's some successful use cases out there when it comes to, for example, vegetation encroachment with railways and roads. And then one maybe last very big theme that we found is the question of how can we actually use this? Is this data that we have to integrate with a team of engineers? Or is this something where we can have a nice map and then it shows the tree in red and we have to fell the tree? So yeah, I would say these are the main pain points that we derived from the industry.
If I may add something from a from the platform point of view, after we developed it and engaging with people who are aware of the Earth observation, people within the sector who are aware of Earth observation, we found that also like when we are talking with people who are aware of Earth observation, so when you listen to their challenges, they are connected to their understanding of Earth observation as well. So one of the challenges that they see that Earth observation can play a big role there. So it was like uh, using the SAR, okay, using SAR for infrastructure stability. We found that there are increasing demand for that using Earth observation, and I think this comes, as I mentioned, from those people who understand the technology. So that means that those people see a potential, maybe a potential for those technologies within the sector. The other one, which is also was important, that in the rail sector, what's important, the vegetation monitoring, for example, or something on the railway. But for example, they have sensors on on the trains themselves to monitor any vegetation coming. But of course, they don't have a sensors to detect what's beside the railway itself. So a buffer zone, for example, of 100 meter or something. So in terms of I th people who understand Earth observation, they see a need and potential of SAR technology and land use change beside around the railway itself.
Yeah, and roads. I mean, you mentioned
Yeah,
railway.
both. Yeah.
I mean, yes, I was going to come in on that because I mean, certainly in the studies we did, it was the ground stability and ground movement that was, some of the biggest and most critical applications. Um, Even linked to regulation in the sense that it's during a construction process or even afterwards, it's possible to understand not just if some movement is taking place, but when it takes place, and hence to link it to work going on and to look at the implications of that in for compensation or just for improving stability of the buildings. Okay.
For the
So
ground stability itself, I think also we found like a big interest on relating it to hydrology, what's going on in terms of
yeah,
water on the ground. So we found that okay, we are interested in ground stability, but how it's correlated to hydrological and things as well. So just as a comment on that, which we found it very widely within the rail. Now I'm talking about the rail community.
yeah. So related to embankment stability, I guess.
Yeah.
Yeah, we found that as well. Did you find any examples where the hydrology mapping was being used alongside stability maps?
I think within the project itself, what we were able to, in terms of the time constraint that we have, is to provide something only including ground stability without the correlation, because it's very complex to have like to the hydrology itself, and we didn't find very remarkable use cases using them.
Okay. See, I'm as normal. I'm nodding away and making remarks, but you can't see me, so unfortunately, the communication's a bit weakened. So, how, how extensive was the regarding use of Earth observation in some form, whether it's through vegetation encroachment or stability? Did you find a large sort of existing user community or a community that was interested but needs to come onto the barriers, needs help in introducing the technology? What was the sort of maturity that you found?
Yeah. I think one of the crucial points of this project as well, there are some, and it's really just some real applications at scale. So one of them being vegetation encroachment, one of them being also, I think, landslide susceptibility we found as one of the things that is actually in use, for example, at Deutsche Bahn. So there are some initiatives going on at scale, but mostly we found this pilot trap that Enes was talking about, and a lot of, let's say, use cases where the value proposition from a technical standpoint is clear or could be easily envisioned, but is not communicated well. And also something maybe to that, another adoption barrier that we clearly found for end users is that once a stakeholder in these very large distributed organizations, right? The railway sector, also the road sector in some countries, these are huge organizations with where the budgeting is very dispersed. And so it's not enough to find one person at one end of a company and then make this use case happen that is actually managed at the very other end of the company. So yeah, in that sense, I think we found one of the problems that pricing is unclear. So to make the internal business case, once someone is convinced, is difficult for the end user. And we also see that the pricing models, this, for example, the tasking-based approach, is difficult for non-technical users then to estimate and to actually make a pitch, right? So probably for this sector, a subscription-based model would also make sense. So there's a lot of these commercial aspects as well that I think lead to some of the pilots being stuck.
What about the degree of maybe use the word importance, but I'm thinking of different products. Some could be some like stability cannot be measurements cannot be made realistically using other purposes, because to do surveys is expensive, and so and the wide scale nature in Norway, the case where the bridge was moving could not have been discovered by any other means because of the large scale of the nature. So there's a very important contribution, as you yourselves have said, for vegetation encroachment. There are other technologies which are used. So it becomes a question of cost comparison rather than a critical technology. What did you find out in respect to criticality and at the other end of the spectrum that you've already mentioned, pricing as being a difficult factor?
Yeah, indeed, these large road or rail operators have more than just a commercial interest, right? There's a security and safety critical aspect, but still, I think there are other means of detecting many of the infrastructure failures, and a lot of the times these are more simple than one might think. To be at the level of vegetation encroachment, how it's usually been done is that project teams on the ground walk along the rails and look. So really, I think the criticality aspect, while it is very important, is probably one that is more difficult to convey to the people with the budget. I think it's rather it's probably better to translate the actual value of the EO in terms of a business proposition. Yeah.
But walking the rail is obviously quite an expensive approach. Although, of course, it's not just inspecting for vegetation, but for mechanical failures or other factors, I guess. So then it becomes a question of the relative frequency of measurement.
Yeah.
Yeah.
I think one thing which was great, we attended like a workshop in London, and at that workshop we met some people, some companies who works in innovation in the rail sector. Okay, not earth observation, not specifically earth observation, but in general, using artificial intelligence or whatever. And one of the things, for example, when you mentioned about criticality, so when we are talking about vegetation around the railway, for as an example, they can put a camera for that. Okay, they can put a camera on the train and to detect if there is any vegetation coming or something. But this camera, that's one where we are talking about the frequency. This camera, okay, we can have frequent updates, but on the railway itself, okay. But what is happening 10 meters away, you cannot see that. So if there is a new building, for example, coming, if due to the floods or something, there is a collapse of a building or something, they cannot see that. But in that case, they need earth observation. But if we are talking about that, again, they need to understand the limitations as well of Earth, so of Earth observation. So one of the things that we were discussing as lesson learned for the Earth observation community, that we need to be very clear about the limitations of our technology. For example, you cannot use very high resolution satellite imagery to monitor daily, for example, but you can say every 6 months, every 2 months, every 3 months. You can do something like that in terms of frequency around the roadway. For example, and now I'm talking the example of the land use, for example. So again, in terms of criticality, as an Earth observation community, we should not compete with the terrestrial solutions in terms of accuracy, because this sector is very keen about the accuracy, very keen. So, and that's why we will have some issues to trust the Earth observation in terms of accuracy. So, from the experience, we should not go that way. We should go, okay, what are the other advantages that Earth observation can provide to in terms of critical infrastructure or other aspects?
Yeah, there's also an issue there of internal expertise, isn't there, and knowledge of what's going on, which is a balance. It's come back to, are you dealing mainly with public or private organizations?
Mainly, so for the demonstrator development was a public organization or let's say a state company. Mainly public, also because this project focused the shift a little bit on rail due to stakeholder engagement. Basically, it was really a matter of where can we get more insights as a practical aspect, right? And that was rail for our project. Yeah.
That question of engagement again. So I mean, one of the things, we talked earlier about the different degrees of uptake, and we looked at 7 different factors that were involved in the uptake. So the geology or the geography in question, whether it's what type of ground there is, what the governance. So how is what's the weight of the organisation? How's it governed? The culture, is there a culture of introducing new technology and innovation? Awareness of space. Often you say, there's a space. This is Earth observation from satellites, and everyone throws up their hands and say, well, yeah, but this is complex and expensive. And so awareness of what can come from space is often important. The presence of an industry, a company, because the company is trying to sell a service, and notwithstanding your comments about being realistic about what the technology can provide, which I absolutely agree with, the fact that a company can help the rail or road organisation with their improve their knowledge of what can be done is important. A champion, an internal champion, can be an external champion as well. In very broad terms, we found that if there was a sort of a mapping agency or an IT agency dealing with geospatial information, that could help a great deal in bringing things forward. And a network of peers. So you talked about having a workshop in London. Did you find much exchange between the organisations concerned regarding what's possible and the best practices?
Yeah, okay. I think the question is for for me. So I think you are going to the very important point. So first thing, the workshop in London was like organized by the organization which focus on innovation in the rail sector, not specifically the space. But that event, it was like supported by the ESA and the UK Space Agency to focus that event on the space sector. And for the space sector, there was 2 things, PNT and Earth observation as well. So I think I think during the project we didn't find a similar event to join. So I think if we have many of such events which focus on the collaboration, because when Earth observation community can go there and meet directly with real stakeholders, I think this something is missing, and and based on the experience that we get in the workshop in London, I think this should be more frequent, and focus mainly on if it focus on a space, it will be more. So for example, when we had the discussion with that group it's called the Real Innovation Group, who organized that workshop, that how can we engage with you to engage with the rail industry. They told us, okay, there is like a subscription plans and others, but it's mainly, it can be like feasible and make sense to join it if you are mainly focused on rail, but this is not the case for the space sector.
Yeah.
So this also is a limitation. So does it make sense to pay and be part of those groups which is only focused on rail? Maybe there's something like big organizations can support companies to be part of those initiatives in a way. This first. Second thing, which is like coming in terms of, as I told you, the event was PNT and Earth observation. We found that the rail sector is more aware of PNT technology or more aware
Yeah.
of GNSS technology. We told them why. They told us because years ago we have Google Maps. So they, okay, now we are familiar with with the technology. When a company come to us and offer something in terms of GNSS, okay, we have like Google Maps as example for something like that. So they told us if we have something in Earth observation, we have Google Earth, for example. But if we like uh, uh, promote it in a way so those people are using it in their daily work on daily life, so they can be aware of the technology itself. Then when you come as a company, they can be more aware and more enthusiastic to hear from you.
Yeah. And that factor is very important in getting support within the company or the organization, because you can have a champion, but then they have to sell it to others in the company. So if there's a network of experts that can help bring evidence together, that can help a lot. But in terms of GNSS, the managers or the decision makers there are basically familiar with it from car navigation and phones, but geospatial information they're not familiar with, so there is a big barrier in that respect. But I absolutely agree. The establishment of these sort of best practice platforms, I think, is a very, very strong way to help introduce the technology and help overcome these barriers. I'm mindful of the time. It will be good to have somebody else come in. I think, Wolfhard, you were the first to put a question into the chat. You've got a lot of questions. Perhaps you could choose one of those and put that first, and then I mean, I notice you deal with pricing, but please, Wolfhard.
Yeah, thank you,
If
Jeff.
you've got your
By the way, I have the same problem as you do. My
yeah,
camera also tells me that it's used by someone else or some other app as well. So yeah, also black square here. But you hear my voice. Let me turn that into a kind of a comment and a question. I think my comment would be the real competition that EO from satellites is facing, typically for this kind of band or linear infrastructure, is a competition from airborne means. If you use drones, if you use ultralight aircraft, or even regular aircraft, it's usually more cost efficient. It's on demand, and you can really, it's cost efficient because you can just fly along that corridor. You can take every turn. So that makes it a lot more interesting for infrastructure operators. We've seen this in along power lines, for instance, when it's about power line monitoring. So my comment would be that if you want to introduce EO from satellite, one of or two areas are really the ones that I would see advantageous, and that would be route or corridor evaluation during the planning stage. We had such a project which was just stopped by the election process in Costa Rica, when they wanted to build their Costa Rica dry canal, basically a rail corridor, because there you're looking at 10 or more kilometer wide strips that you have to cover. So that's the one. And then the other one, and Melanie also hinted at it, of course, is what was mentioned here by both presenters, is of course the use of INSAR. If you're looking at slope stability, and Natural Resources Canada has introduced that to Canadian rail in areas not only in the Rockies but also in eastern Canada, where slope stability is a major risk for rail operation. So that's something. Those are two areas. But now my actual question would be: is how do you, and that goes to both presenters, how do you see the competition against, or is it a combination even with airborne means? How can we establish a business in this kind of ecosystem, and what would need to change in the pricing model and the business model of satellite image providers to make this actually cost effective and competitive?
Yeah, so we thought about this a lot during the project, and also at the very beginning, of course, we mapped a little bit what drones and plane-based surveys can do, and I think there's the clear message should be EO is a complementary layer that you can use to get consistent data over a large area regularly, while with the drones or aerial surveys, you have problems sometimes with flyover regulations. You can't do this everywhere. It is expensive if you do it as regular as you do it with EO. So in the end, I think EO strikes one of the nice sweet spots. And to the pricing, I mean, pricing is relative, right? Pricing is always the question of what kind of value can you actually unlock for the end user. And here we've seen a clear lack of communication of the sector towards the end users. Is what does it actually mean for your KPI? What does this mean in percentage of OpEx, right? What is in a low, medium, high scenario, what we can actually deliver? And I think if you build if you're interested in that, we built a business case around the flood risk tool in the best practices. These will be published in the coming weeks. And yeah, we tried to do this, and we actually found that this flood risk EO tool in a conservative scenario could save something like 2% of OpEx over the project lifetime. Of course, this would be a tool that is completely finished, right? That does everything that is supposed to do. But still, I think pricing from a cost perspective, it looks expensive, but depending that you can unlock, it might very well be worth it to support advanced models.
Okay, thanks. And I mean, the question of building the business model is obviously quite critical, and getting alongside the organisations to help them with that is really very important. Emmanuel, you want to come in? You make a nice point about the internal capabilities and either contracting out or building internal capability.
Yeah, thanks, Jeff. By the way, nice piece, Rama, Jeff. So my point is the following. Across different contexts, I noticed that engineering firms involved in building, road management, whatsoever, they have ground solutions. And they are more and more paying attention to aerial and even space solutions. Either they are buying companies, such as Woolpert, they acquired Murphy Geospatial, or some others. I can give you an additional. Fugro with EOMAP in another domain is exactly the same story. Fugro was ground-based. They acquired EOMAP in order to bring to them space-based capabilities. So either they are buying or they are developing in-house. And my question was, did you notice this trend as well when you discuss with not only end user, but the guy providing services to end user, so engineering firms, or not? Thanks.
Yes. Yeah, we noticed this. So actually, insurance risk premiums are part of our business case, first of all. This is always it is always insurers are most of the times the first group of stakeholders that are buying new kinds of data in order to decrease their uncertainty about risks. So for example, natural hazards, how we looked at how do they calculate usually their insurance premiums. And of course, there's the expected annual damages to an average segment. And then there's the risk load factor that's based on certain segment characteristics, for example, prone to flood risk or ground instability. And then these risk load factors are the actual cost driver behind insurance premiums. And if EO can convince insurers that they can deliver a certain higher percentage of accuracy over the whole network, right? We're not talking about point accuracy. We're talking about the overall network can be better estimated in terms of risk. Then this is something that insurers are very much willing to pay for.
Another model there has been developed in Italy, where when they contract out the engineering works, they mandate that the contractor must use stability maps in order to monitor the work that's going on. Not for all projects, but essentially for projects where they perceive there is a higher risk. So they sort of outsource it, but they've built an internal knowledge to know the way in which the engineering companies are using the information. Okay, thanks, Emmanuel. Deo Elbeck, you've had a couple of questions. Do you want to come in? Jürgen, I'll come to you in a minute.
Right. Yes. I will ask the last of my two questions, which is about the accessibility of geospatial data and the costs, because I think someone here, it was Ines or Marius, who mentioned that you use Google Maps or Google Earth. So I was wondering, what about the accessibility of public data?
So you're referring to, for example, Sentinel derived data?
No, I mean other data, which is ground-based data. Are those not free and accessible for companies in other European countries?
So specifically for this project, we didn't really look at this. For an adjacent project, the EO best practices for solar, we've talked to stakeholders that said, wait a minute, there's for example in Germany there is regular every 3 years there's a aerial LiDAR survey, for example, and then this can be used, this data can be used, and this is of course true, but this is very region specific. So it's not that there's free data easy to use everywhere. And then also this takes a lot of expertise to incorporate, right? This is also cost in the end to make an insight out of this data. So another thing that we've frequently encountered in interviews is when we were trying to derive a user requirement in terms of, okay, but how big is this? Do you need 10 meters? Do you need 20 meters? People sometimes just said, I don't really care. I just want to know if I have to fell this tree. This is the only thing that I want to know. And so public data, even if it's available, is not always the solution. Although, and I'll give this to Enes, I think, Enes, you have a good experience with building the demonstrators also on some public data sets, right?
Yeah, I agree with Marius. I think all the stakeholders or the end users wants to answer their question or to solve their problem. They don't care. Maybe they don't know what does resolution mean. They don't know. What they care about is the solution itself. If it can be by public data, it's okay. Other sources of data, it's okay as well. But when we talk about the the solution itself, when we talk about the solution itself, usually in many cases, I think you need you will need some non-public Earth observation data, whatever for SAR, for example, or for land use change as well, because you need, as we discussed previously, to compete with aerial imagery or ground data, so whatever. So in terms of INSAR, for example, okay, Sentinel-2, the end users, Sentinel-1, sorry, can accept Sentinel-1 when you are talking about like the national wide railway or the roads. Okay, they are accept, okay, give us where the potential risk can be, but they still aware that they are aware if you go for a smaller area, do you know that very high resolution INSAR technology would be needed there? Yeah.
Jürgen, if you still want to come in, raise your hand again. And Melanie, I take your comment as a comment, but if you want to come in, also raise your hand. If not, I'll go to Amis, who from USPA, who has a question. Amis.
Yeah, hi, my name is Arnis. Yeah, you mentioned that you feel that technology is there and it's capable enough to deliver some value, and it's the other aspects that are blocking. Did you maybe talk and see how companies, how infra managers that already have deployed at network scale different types of monitoring as vegetation monitoring in Deutsche Bahn or Network Rail in UK? They are signing the second contract to extend the network scale monitoring and implement the services quite deep into their operational activities. How did they achieve these barriers that Jeff previously mentioned and you yourself? Is there anything to be shared and learn for others? Thank you.
Yes. So of course we don't have the inside, let's say the inside view of this, but judging by, so I don't, of course we're not trying to promote any individual companies here, but if you look at the even the company websites of these companies that are integrating into these large railway companies, these EO providers, their websites are also set up very much about the value business proposition, use cases, very clear niche applications as well. And I think it's not at least to us now after this research, it's not a big surprise that something as specific as vegetation encroachment is one of those use cases that in the end is scaling up to commercial operations, because it's such a specific niche. There's a real cost pain point. It is clearly derived from the business process pain points of the end user, and then this value proposition. How it was exactly phrased, we are not sure. But having now formulated a business case, I would also guess that it's related to showing the status quo cost, showing where in this equation of cost the EO value proposition can change a parameter. Maybe it's an improvement by a few percent here. Maybe it's even deleting a whole cost factor and then just adding the EO cost on top. But it's most likely going to be related to something, which is a financial business case, is my guess.
Yeah. Yeah, one more thing I think we found in the UK, for example, for the network rail. When you see, I think those the railway sector, those people know the technology and knows good about Earth observation. As I told, there are some teams they are fully aware, and they had in the past many pilots, so I think they knows exactly what they need, and then they map the market and see which companies can provide a really vic, vic, vertical knowledge in that topic. So, for example, they can have many companies doing some pilots in land use change, okay? But when they go for like operational thing, they may choose Airbus because they know that they can have a good business case because of having the very high resolution satellite imagery. They understand that the cost in land use change comes from the purchasing the very high resolution, so they will go for companies who have them. In terms of INSAR, they know that the technology is there, but when they want to implement it, for example, in the UK, they have it they can choose the company who has a vertical knowledge in INSAR to do operational phase. As we see, I think in the network rail, there is a case now by company to do some second phase as you mentioned. So I think the people in the railway sector are clever enough to choose the right company to do their work in terms of money and in terms of knowledge.
Okay.
Thank you.
It's turned to Jürgen and as a sort of a last comment or question, and then we'll close down. Jürgen.
Okay, hello. It's more to Aeneas, to Ennis. It's after my opinion, what I encountered, and I made some projects with INSAR, with sentinel ground motion data, also with high resolution data. And I think the main problem for all rail operators is they need constant information. It doesn't help them if they have some points where they don't have information about, for example, ground motions or about hydrological conditions. Another aspect is also, after my opinion, the water risk. They search a lot for, they have a lot of engineering problems in depths of about a half meter, and they're doing some georadar campaigns and cannot get the precise information what's going on in 1 meter depth. I think these informations are quite valuable. For vegetation, I think they are using less remote sensing because they are installing more and more cameras on the trains, and they are using it also internally. They have really high-skilled people. The problem is in these companies, there's a big change of positions, and sometimes it's hard to find the right person. But after my opinion, when we have to provide solutions, we have to provide solutions in a form that the rail operators, the simple operator, can use it in his handy, and he sees, I have this information at kilometer or meter, so. And there we have to find a way to deliver the data in this way. Nobody will download big data sets and try to implement it at rail. So I think it's also on our side to provide a solution who may fit for this. And we are speaking all about EGMS data or something else. They won't download the data and put it in their system. And I think that's more or less a limitation.
Yeah, fully agree with you. You should like try as much as possible to avoid technical language as much as you can, because as Earth observation community, we used to be very technical, very scientific, and I think we should start to be more end user focused don't show our capabilities. We can do that. We can do that. You can download the data. You're showing our capabilities. They don't care. They care about, like, in their mobile phone, as you mentioned. They can see a report every day. They can see
Yeah.
a map every day. That's what they don't care. And they just tell them the accuracy is 90%. That's it for them. Don't go for much detail. They don't care. And say with this technology has been like used and developed in somewhere else and provided those values. In such case, okay, they trust and they use it, of course. And of course, you provide in a somewhere different a validation report and scientific report, everything, if they want to go and make sure of everything. But in their hand, they should be something very, very, very simple.
Yeah. And it's like learning a foreign language to go into a new end user industry. Of course, also in my consulting work, I encounter this regularly to address new user needs in new industries. It is difficult. It is a lot of work. And now also building a business case for road and rail certainly also gave us a new respect for actually how difficult it is to deliver this value proposition that EO could have.
Okay, thanks, Rose. I always keep in mind that it also depends on the phase of the work. We've focused quite a lot there on the operational phase or maintenance phase, and during the engineering phase, the design and development phases for projects, there are also complementary applications that can be used. But thank you both very much for joining the call. We're a little bit late, so I will lead on to close the EOcafe at this stage. But as usual, for anybody who wants to stay on with us, we keep the line open, keep the cafe open, and it's sort of almost an open mic. So just open up your microphone and join in. Apologies again for my lack of video. That's very annoying. I thought I'd fix the problem, but it hasn't. And quite clearly, the camera is not in use because it's not activated. Just also a final reminder for people on this particular subject that on the Earth's website you can find links to all the SEBS work. There's an area devoted to SEBS, and there you can also find projects linked to road, less to rail, but certainly to road infrastructure. Next EOcafe is on the 4th of December. We'll be talking about the SDGs and how they evolve the use, or how the use of EO can help with SDGs in the post-2030 framework.